Hello everyone, I'm gonna introduce our paper WaterMask instance segmentation for underwater imagery for you.
Instance segmentation is valuable in estimating object interactions and inferring scene geometry. It is of great use in many underwater vision scenarios. However, the segmentation of image instances for general underwater scenes has not been thoroughly explored.
As for the motivation of our paper, the first one is that there is no general underwater instance segmentation dataset. On the other hand, quality degradation of underwater image is inevitable. So low quality images often lead to failure of current segmentation methods. To address the issue, we propose the first underwater image instance segmentation dataset, aiming to promote the development of instance segmentation for underwater tasks. Simultaneously, we propose WaterMask for multi-object underwater image instance segmentation according to our underwater imagery. As for our contribution, the first one is we construct the first general underwater image instance segmentation dataset. The second one is we propose the first underwater instance segmentation model, WaterMask. In the WaterMask, we designed two modules to reconstruct and refine the image features, and we use boundary mask strategy to optimize the boundaries. And we did extensive experiments on popular evaluation criteria, which demonstrates the effectiveness of our dataset and our method. Let's check out some images in our dataset. We can see that there are many categories in the images, and we can see that the boundaries are clear. This is how our method looks like, and this is a very brief structure of our WaterMask. I'll introduce to you one by one. The first one is different similarity graph attention module. Underwater images generally suffer from quality degradation. However, underwater instances are mostly clustered, which make it possible for underwater images to have similar visual information. Therefore, we propose the DSGAT module for collecting this similar visual information by computing the attention. The next one is multi-level feature refinement module. This module will repeat twice. Features with larger reception fields will be used to predict the mean body of instances. And the second time, it is used to predict the boundaries. After last two stages, features with different resolutions will be used to predict masks with different resolutions. This is the comparison between our method and baseline frameworks. As we can see, under same configurations, our WaterMask outperforms almost all other methods. We also present our proposed WaterMask and compare it with the SOTA method. In this table, we can see that the WaterMask outperforms traditional natural image instance segmentation algorithms. Additionally, WaterMask is also highly competitive when compared with SOTA algorithms that utilize transformer structures such as mask transformer. This is the qualitative comparison on our proposed data set. So we can see that in some images, our WaterMask method outperforms the other two methods by a large margin. We did extensive research on ablation study in which we proved the effectiveness of each component in WaterMask. Let's conclude our work. The first one, we have constructed the first general underwater image instance segmentation dataset with pixel level annotations. According to the intrinsic characteristics of underwater imagery, we have proposed WaterMask for underwater image segmentation. As for the future work, we plan to extend the datasets to broader and more challenging underwater images and underwater videos. Thanks for listening.